Dear students, in this video we will talk about metallic bonding. And so we know that the metallic bonding is one of the primary type of the bonding which is found in the metals and their alloys. Metallic atom can contribute more number of the valence electrons as compared to other materials. For example, we have an example of iron. Here, these first, second and third shell electrons are called as core electrons. These are the complete shells, and electron in these shells are called as core electrons, while the electrons in the outermost shell are called as valence electrons. The core electrons cannot take part in the process of bonding because these electrons are tightly bound to the nucleus. So these core electrons along with the nucleus make positive ion cores, while valence electrons are free to take part in the process of bonding. So this is the schematic presentation of metallic bonding. These are the positive ion cores and these are the free electrons. So every metallic atom contributes its valence electron to take part in the process of bonding. These valence electrons are free to move around all positive ion cores. So these valence electrons are not bound to any particular atom in the solid. Rather, they are free to move throughout the entire material. So these free electrons make the electron cloud or electron sea. Many properties of the material are due to this type of metallic bonding. So here in this video we will discuss the different properties of the materials which are due to the metallic bonding, like the electrical conductivity, thermal conductivity, the malleability of metallic materials and their ductility. All these properties are due to metallic bonding. So here first of all we will discuss the electrical conductivity in the metal. Here you can see that this is the piece of copper wire. When the copper wire connected to the battery, it conducts electricity. So how it conducts electricity? As we know that the copper is the metal, so this is, here you can see that in the copper wires there are the positive ion cores and there are the free electrons. These electrons move randomly around the positive ion cores, but when we connect the copper wires to the battery, so under the potential difference, these electron moves from one terminal of the battery to the other terminal of the battery. So under the potential difference, in copper wire, the electrons are readily available to conduct the electricity. So the electrical conduction is due to the metallic bonding and due to these free electron sea. So this is the one of the property of the metals, that is its electrical conductivity is due to its metallic bonding. Another important property of the metal is their thermal conductivity, that is metals can conduct thermally or metal can conduct heat. That is, when a piece of metal is heated by any external source, then it will increase the kinetic energy of the free electron. So these free electron moves randomly with greater kinetic energy and transfer the energy from one electron to another electron. So in this way these free electron can conduct the electricity in the metals from one point to another point. So thermal conductivity is also due to the type of metallic bonding are due to the presence of free electron sea or electron cloud in the case of metals. Another important property of the metal is the malleability and ductility, and malleability and ductility is also due to the metallic bonding. Now, malleability is the substance ability to deform under the pressure, like under the compressive stress. So it is the ability of the substance, usually of the metals, to be deformed or to be molded into different shape. If any materials is the malleables, and it can be flattened into the thin sheet by hammering or by the rolling. Malleable materials can be flattened into the, we can say that it can be flattened into the metal leaves. One well-known example of the metal leaf is the gold leaf. Many metals with high malleability also have the high ductility. Malleability in the metals occur because of the metallic bond, and that keeps the atom in place. So when we hammer the materials by applying the compressive stress, so it's the metallic bonding which keep the different atom in the place that is still there when you hammer the material, or when you apply the compressive stress, still there are the positive ion cores, and there are the free electron or electron sea moving around these positive ion cores. So it is the ability of the solids to bend or to be rolled or to be hammered into different shapes without breaking. So it means that when we apply the compressive stress in the metals, still we cannot break these materials, and it means that still there are the positive ion cores and there are the electrons. We cannot break the bonding by applying the compressive stress or by hammering. So these materials change its shape or without breaking. In other words, we can say that it is the property of the metals to deform under the compression and take a new shape. Examples of the malleable metals are gold, iron, or it can be the aluminium, or it can be the copper or silver. So as we know that when metals are malleables, it means that these are ductile as well. Ductility is the ability of the metals to receive the permanent deformation without fracturing. So metals are malleables and ductiles, and these two properties are due to the metallic bonding in the metals. This one is the stress and strain curve. Here you can see that when you apply the stress, then there is the strain. For example, for the brittle material, when you apply the stress, then after certain limits, then there will be the fracture point. That is, material will get fractured or it will get shattered. It is for the brittle material. But if the material is ductile, or it is then it will be the malleables. Then it means that when you apply the stress, then it can absorb the energy. Then it can absorb that stress, and it deformed without breaking. It can deform its shapes. It's change its shapes without going to fracture. This is for the ductile material. Another important property of the metal is that the metals are low volatiles. Their volatility rate is very low. This is because of the metallic bond. As in the metallic bonds, the electron cloud or electron sea, that is attracted by the number of positive ion cores. So these free electrons are not particularly attracted by the single positive ion core, but rather they are attracted by number of positive ion cores. So there are the strong attractive forces between the positive ion cores and the electron C. So because these strong attractive forces, the metals have the low volatility. As a result, their melting and boiling points are very high and high density of most of the metals. So this property is also due to the metallic bonding. Another important property of the metal is that metals are the lustrous, that is, metals can shine. So, this property of the metal is also due to the metallic bonding, that is, the electrons that are farthest from the nucleus. It means that valence electrons, that is, the free electron or electron C. So, when light falls on the metallic surface, light gets reflected or can be bounces off from these outer electrons. So this makes the metal appearance shiny. That is, when there are the more number of the valence electrons, or when there are the more electrons, free electrons in the electron sea or electron clouds, when there will be the more reflections of light. When there will be the more reflection of light, then metal will appear shiny or lustrous. So the example includes like the silver or gold or platinum. So all these metals are the lustrous or the shiny metals, and this property is also due to the metallic bonding. Thanks for watching.